Good morning and welcome everybody. Thank you for joining our Smart Local Energy System event. This event is hosted by UKRI with Net Zero Week. My name's Nick Windsor. I have the honour to chair the first session. I'm also, as some of you will know, I'm chair of the Energy Systems Catapult that does a lot of work on local energy systems, and also chair the advisory group on Prospering from the Energy Revolution, which is, as you'll hear later on, focusing on local energy systems. My job here today is just to prepare the wicket, because we've got lots of great batters and bowlers coming. I will just say this, given that I've got a chance to say something at the beginning. SLES is one of the most poorly understood components of the energy system of the future. It will be absolutely essential to an economic and efficient transition to zero carbon economy. Currently, we optimize and operate essentially from a national or wholesale level. In the future, we will need to optimize and operate at a local, or we could say retail level, to use the plethora of local generation options, demand flexibility, and storage options. This will be vital to the economic transition. That's all of the advocacy from me this morning. I'm going to let the other speakers carry the ball forward from here. Over the week, we have a number of sessions going right through to Thursday. Today is the overview, big picture. Tomorrow focuses in the morning on the business of local energy, and in the afternoon, finance and investment. Wednesday, local authorities, planning, the Catapult toolkit that's coming out of the PIFA work. And then in the afternoon, communities and customers. And then Thursday, a wrap up and look forward. I should just let you know that these sessions are being recorded and published online. There will be an opportunity for questions at the end of this session. And there's a virtual exhibition, which I think is already open, but you can look at in between sessions or after sessions. You can see on the screen the agenda for this morning, which I'll introduce the speakers as they come, but an excellent set of speakers, David, Juliet, Caroline, and then Rob from Innovate UK. So that's all from me for now. I'll go straight into welcome David Joffe, Head of Carbon Budgets at the Committee for Climate Change. David, thank you for agreeing to speak today, and over to you.
Well, thanks very much, Nick, and good morning, everyone. It's a pleasure to speak to you, and I have the opportunity to say things no one else has said yet, apart from Nick. Otherwise, I might be agreeing vociferously with people who went before me. So I'm going to give you an overview of the carbon budgets that all of this smart local systems needs to deliver against, and some of the local delivery challenges. Okay, so moving on to my first slide. So this gives you an overview of the emissions targets from now to net zero by 2050. We recommended the 6th carbon budget in December, which has now been legislated as recommended by the committee. And that requires a 63% reduction in emissions by 2035. So halfway through the period, 2035, we need to have more than 2/3 of the reductions between 2019 and 2050. That means a lot of action in the 2020s. It's both action to reduce emissions during that decade, but it's also the actions required to prepare the ground for the rapid reductions also in the 2030s. So there's some strategic decisions required in the 2020s that won't necessarily even reduce emissions by very much before 2030, but are absolutely crucial. So the 2020s absolutely is the the essential decade in terms of getting on track to net zero and really preparing the ground. By 2030, we should have almost every new light duty vehicle being low carbon. We should have the majority of heating appliances being installed that are low carbon, etc., etc. So as well as getting the emissions reductions there, we need to have a framework that's going to deliver subsequent emissions reductions. Okay, so moving on to how do we achieve those targets. This is a wedge diagram that basically shows the contributions of different ways of reducing emissions out to 2050, but this was underpinning our advice for the sixth carbon budget, so setting the target for the mid-2030s. You can see we have a kind of a set of wedges at the top on the demand side, which are really important and can deliver a lot in the next 10 years, but then they just don't keep growing after that in our analysis. So really important for the near term. That's both reduced demand and improved efficiency. We've got decarbonising existing energy, and then a huge wedge of electrification, and we think that's really important, and I'll come back to that, but that's really important in our analysis. We do assess that there are some areas where you can't electrify, and that therefore something like hydrogen is going to be required. We have that focused in the areas where you can't electrify, and we think that's sensible because of the challenges of producing zero or low carbon hydrogen. And then we have some carbon capture and storage in industry, and we have greenhouse gas removals to offset those areas that we think there will still be residual emissions in, such as agriculture, such as aviation, even by 2050. So I just wanted to emphasize here the massive contribution of electrification. It's the biggest single wedge by some distance, and it dwarfs the contribution of hydrogen, which people often think, oh, hydrogen's amazing. I think hydrogen's really good, but I also don't think we should be trying to do everything with it. So 4 times as much emissions reduction comes from electrification in our analysis compared to hydrogen. Okay, so moving through into what does that mean for the energy system and smart energy. We've modelled this at a kind of an aggregate level, a national level, and clearly haven't caught all of the local variations, and I'll talk about that in a minute. But we do have quite a lot of smartness in our analysis. I won't read out all of the elements that you can see on the screen, but essentially, there's a lot of assumed smartness going on here. Now, we probably haven't got it right. We almost certainly haven't got it right in terms of the right mix of smart solutions. But in a sense, that wasn't our job. Our job was to say, there is a path here to get the emissions reduction. It will require some smartness. Here's what we've modelled, but the solution actually could be something different, and it could be better or lower cost than what we've modelled. So I'm not in any way pretending that the mix of smart solutions that we've got in our analysis is exactly the right one, partly because we can't model everything brilliant, at that fantastic level of detail, but also because, and we'll hear this later, I'm sure, some of these solutions are still emerging. It's relying on technologies that have only just come to market, for example, and so on. So this is a moving space, and we will discover what exactly the best smart solutions are as we go along to some extent. So that's the energy side of it. I wanted to move on now to the local side of things. We had a piece of work done by a colleague, Louise Marix-Evans, on local delivery specifically, alongside our sixth carbon budget advice. We think this is a really important area. We think it's a much neglected area, and she did an excellent piece of work. The report is on our website, and it came up with these fundamental 4 priority recommendations: that we need a framework to deliver net zero that combines the national level responsibilities and the local level responsibilities, and a collaboration between those levels. We need a financing capability to actually help deliver this. We need the flexibility to deliver things in different ways in different parts of the country. And we need facilitation to ensure that policy from government departments is net zero compliant, and that things don't try and pull in different directions. So that's really important, and that will have to underpin then delivery of local smart energy solutions. Moving on then, I mean, clearly local areas cannot, in terms of local decisions, they cannot solve every single challenge in terms of emissions reduction. We will need national policy to create the right incentives, but we clearly have a lot of ways that local delivery can vary in different parts of the country. We have huge enthusiasm in many local authority areas, and the question is, how can we harness that? And we need people to be engaged in making those low carbon choices and not just have them imposed by people who don't know the local area and are making top-down decisions. That engagement is important, not just for choosing the right solution. That engagement is valuable in itself. We need to get people engaged in the net zero transition, and this is an important and valuable way to do that. So it's important to recognise over 90% of local authorities have declared some kind of climate emergency or net zero target. They can't control all the emissions, but it's very important to embrace the opportunities for the local action combined with the top-down action, and the cross-boundary issues as well of neighbouring local authorities. We need collaboration between local authorities to ensure that solutions that are being deployed in one place make sense across the region. And we do think there are different levels of decision making as well. There's national, there's local, and there's something in between. For example, if you're deciding on hydrogen supply, that might be a regional decision rather than a local one or a national one. So there are different scales, and we need a framework that combines those. Finally, specifically on local area energy planning, I mean, we see this as a sorry, I just stepped through the various aspects here. We see this as a really important way. It's not so much optimizing local area energy systems so much as a process for deciding what should happen. And that process, of course, must take into account the local geography and ideally some modelling about what might be least cost or close to least cost. But it also has to engage with stakeholders, including the people who live in that area. So we think this is a really important aspect of local area delivery. But we have said, and we first said in 2016, that the decisions on how you decarbonise heating in different parts of the country would need to be made by 2025. We're now in 2021 and we haven't moved this agenda on enough yet, and that makes the next few years crucial in order to actually get to where we need to be able to make the decisions in a timely basis, but in a way that actually does it properly and engages with local people. So that's my final slide, and I'll leave it there, but happy to pick things up in the Q&A later on.
Thank you, David. Thanks for a great start, giving us the high-level view of how this fits into the CCC's, really, I'd like to say, really excellent work that we all keep an eye on. So with that good start, we're now going to hand over to Juliet Davenport, Executive Director of Good Energy, founder of Good Energy, of course, who's going to address us on the topic of this very bold title here, Renewable Nation, Pathways to a Democratic Zero Carbon Britain. And can I just say before Juliet starts, if you want to post a question, just put them on the chat. And we'll pick those up. Ideally, say which speaker you want to address the question. Thanks. Over to you, Juliet.
Thank you, Nick, and good morning, everybody, and thanks for asking us to come and talk this morning. Nick, I love your introduction about how important the local energy systems are going to be in the future, because I do see you as a little poacher come gamekeeper, as a result, having come from a very centralised world. And I just kind of want to remind people, I guess I've stepped down as CEO of Good recently and thought back to when Good was founded. And that was around 20 years ago. And at that point, I think 2% of the electricity generated in the UK was renewable. I think most of the power in the UK, and Nick, you can correct me if I'm wrong, came from about 38 generators. Today, we are in a significantly different position. We're closer to sort of 45% of our electricity coming from renewables, and with over around 1 million renewable generators on the system, mainly decentralized, so connected to the local grid. So we see a very different situation already over the last 20 years. And our view is that that is going to accelerate to be able to deal with this zero carbon. So let me tell you a little bit of history of Good and then why we did this particular paper. So Good Energy came into the market to, my background as a climate scientist, was interesting in challenging the energy system to become more low carbon. And the route in was through looking at becoming 100% renewable and understanding what that really meant as a supplier, trying to balance renewable in every hour of the day and what that meant in terms of bringing more renewables onto the system. Through that journey, we went through a route, to be honest, entering the energy market at that point was quite challenging, I would say. And actually being able to contract for power was really challenging because a lot of the big players didn't want to contract the smaller players. So we ended up contracting with lots of small generators because they were on the similar terms to us. And essentially we became a specialist in small generation and understanding that marketplace, understanding how to access that market, how to get small generators to be part of an overall system, and really passing benefits and balancing the power output from those sides. So the history of this particular piece of work, which was that Good decided to work with Energy Systems Catapult on looking at, okay, so what happens if we take some of the great work that the CCC has done and other organisations in the UK and kind of turn the renewables up? So how do we turn renewables up? And what does that mean for the system overall? And how do you deliver a low carbon system in that situation? So if we go to the next slide, please. The considerations that we kind of had for this were to really look at sort of what were the key barriers to bringing in significant amounts of renewables. So first of all, R&D. So research and innovation is really the mainstay for what's going to happen in the next 10 years. And understanding where the UK is spending its money in research and innovation is really important. The next part is infrastructure. So whatever infrastructure is being built, right now we know local grid and national grid have constraints related to renewable energy. That infrastructure is a key piece to being able to deliver a future low carbon world. The regulation, most of the regulation has been written over the years in a high carbon world where you have marginal cost of electricity being generated by either gas or coal plants. In a future when it's mainly renewable, that needs to change, and we need to rethink the regulation to make sure we're sending the right stimulus through to the marketplace. Consumer, and I think CCC highlighted this, but also the most recent IEA report highlighted that consumer is going to be a key part of delivering this low carbon world. And finally, and I'm not going to get into skills, but just a nod to skills. Skills is really important. We're going to need a different set of skills to deliver this new world, and understanding then to transition in that. And I know that we have the new Green Jobs Task Force is really important to be able to deliver all of this. And before I go to the catapult, one just thing on R&D, just so you know, is that the majority of R&D in the UK has been spent either in medical, aerospace or automotive over the last 10 years. I think most of those we spend between 3 and 4 billion a year over the last 10 years. If you look at energy, it's 0.2. So energy is really the poor cousin in research and innovation. And my view, particularly in this decentralized world, is we need to up that spend if we're going to deliver on this decarbonized world. And I don't work for the Energy Systems Catapult, just so you know. So what is this report? So what we did is we have a team at Good Energy who are expert in trading decentralized energy and decentralized power. And what we did is we kind of crawled all over. We went and worked with Nick's team up at Energy Systems Catapult and really understood, okay, what are the biases in models? All models have biases. No model is ever perfect. My background is I started as an energy modeler before I even got into this. And what you absolutely know is you have to, the input that you put into those models and the way you allow the models to maximize within them, whether it's economically or spatially, is incredibly important. And there's always a bias towards existing dominant technologies because they tend to be there already. And they also tend to have all the pricing there already. And the granularity is also quite difficult. So you have to make sure that when you're working through with an energy model, you challenge it from lots of different ways. So what we did is we took a baseline of the ESME model and just ran it just so that we knew what it looks like normally. And then we started to play with it, and we played with it. The first one, we turned something called res to 11. Anybody who has a Spinal Tap reference will know what that means. So basically we turned renewables right up, just on their own, with nothing else being turned up, just right up. Now that is an expensive way, because what you end up doing is you have to deal with the flexibility that you need by adding more renewables. So that's an expensive scenario. Flex revolution is where we bring in flex. So flex comes through, whether it's local flex or national flex comes through heavily. H2 economy is where you push the hydrogen economy, and we went for big on hydrogen. And the last one, which I always find slightly difficult to explain because unicorns mean many different things, but this unicorn is there's no mythical technologies. So this is no technology that doesn't economically exist in this last scenario. So we kind of worked through these different scenarios. We found some things out. Really interestingly, if you turn up hydrogen on its own, it goes blue. And I'm sure everybody knows what that means. And it actually pushes out green hydrogen. So that's a big challenge because of the cost of green hydrogen. No unicorns is really expensive scenario if you just leave it on its own. So where we got to in terms of a renewable scenario is by bringing Res 11 and Flex Revolution together, as you can imagine, delivers a zero carbon Britain. And zero carbon Britain, I'll come into what that means in the next slides. Can I have the next slide, please? Oh, we're on key findings already. Sorry, go back one. So on the key findings, electrification of everything. Electrification is very important, and I think, David, that backs up what you've already said. It dominates across heat and transport. People power. We're going to need significant delivery of energy efficiency and home storage and home generation if we want to deliver in this decentralized way. So that means that people are going to become an incredibly important part. So households will be part of the energy infrastructure. So it doesn't just get to the grid to come into your house. The grid kind of goes beyond the meter and into the home. We can get to 98% renewable, so not quite my 100% target, but 98 is not bad. But it does need other new technologies to come in. So that's marine, really important. So that should be in its R&D phase at the moment. And geothermal, again, another technology in its R&D phase right now. Storage and flexibility are absolutely crucial to this. We need large scale batteries, we need pump storage, we need everything we can to throw into the scenario. So again, we need some more research going into that. And that's going to include some of the knock-on effects of storage as well. So what happens in the mining sector. So we need to be thinking holistically about the storage sector. But what's interesting is that the low carbon scenario is the same as the base scenario in terms of costs. Because we can reduce the cost because we put flexibility in there. I'll take you through the numbers in a minute. Essentially, the investment goes into households and making people's homes warmer is a really key part of this scenario. Can I have the next slide, please? This is for all the people who like to figure out what happens when the wind doesn't blow. We are not allowed to run a scenario on the energy systems catapult model without putting it through a stress test. And this is exactly what we did in this scenario. And the key thing is, so Good Energy today balances half hourly. So we have a mixture of wind, solar, biogas and small hydro in our portfolio at Good, and we balance between 85 and 90% in a half hourly basis. So the kind of piece that you're looking for is that extra 10%, and that's what we stress test. So we stress test this through here, and that's why you've got roles for tidal, which can almost become a baseload technology, geothermal similarly, and some wave, not a huge amount of wave. One thing we proved is that you don't necessarily need another Hinkley, you don't need power beyond nuclear beyond Hinkley C. And one of the things that we did find in the scenario is that more nuclear tends to clash because it's so inflexible with large offshore wind. So when you bring in large offshore wind and nuclear, it doesn't actually work that well together because you need gas backup generally. You've got huge deployment of both grid scale storage and domestic batteries and solar panels, and over 50% of homes with solar panels. That means that we basically put solar panels on every roof in the UK that we can. Next scenario, next slide, please. This is just a really high overview of kind of what the mix looks. So not unsurprisingly, offshore wind is really dominant in this. So that's a sort of large central, but then onshore wind is important. Large scale solar is really important in this. Domestic solar, tidal, wave, geothermal is also important as tidal. And then hydro and Hinkley. Can I go to the next slide, please? So if we look at renewable heat, the key technology in this, there is some hydrogen, but again, as David said, it's not massively important. It's the hard to heat areas that it really goes into. Electricity and district heating. So district heating is quite often with electricity. So it's a heat pump district heating system. But you can see the amount of electrification that goes into this. I think the other is probably a sort of small amount of biomass coming through in terms of that technology. Next slide, please. I mean, I think most people are convinced of the electric revolution in the car manufacturing business. We're already seeing that step through. So that is consistent with this. We see some liquid fuel and some hydrogen in this sector, mainly to support sort of heavy goods vehicles and again, difficult to reach areas. However, one of the key things and one of the key applications, and we're beginning to see that come through a little bit in research, is that flexibility in smart EV is absolutely key to this. You cannot do it with anything. So you can't be putting your electric car on at the same time as you're putting your kettle on in the middle of the World Cup final. So that is really important, and we need to make sure that cars and chargers and charging points are facilitated to make sure they can all do smart charging. So next slide, please. Coming to the cost. For me, I think the really important thing about cost is actually this scenario is slightly cheaper from a cost point of view from the electricity generation, so the investment point of view. And that's because we put so much into energy efficiency costs. So energy efficiency reduces the overall cost and the overall need for significant amounts of renewable generation or large-scale generation. Energy storage is also slightly lower because of the energy efficiency side again. Same with electrical backup. Electricity networks, Nick, I don't know whether that's music to your ears or not, but there's an investment needed in those because obviously we've got a decentralized network grid. So we're going to need more investment to be able to deliver that. And as I said, energy efficiency is important. Gas and H2 networks is more important in this one because we still see hydrogen as an important technology. Interesting, just so people understand, there is no biomass in the electric side because most of the biomass is considered in this model to go into hydrogen. That is a question mark, but it means that you're not using electrolysis in the same way. So that is what the model decides to do, is to use all the biomass in the UK, not for electricity, but for hydrogen creation. So if we just go to the last slide now. So the kind of principles that we come out with from this is do the known now, take the technologies that are already delivering at low cost and deliver them now. Unleash people power. So the investment in energy efficiency and home generation is key to this scenario. And it's and my personal view, I just think it's a no-brainer. Making our homes warmer and more resilient in this future world will help up with a levelling up agenda, will help up with a decentralised agenda. It's a huge piece, and I think we really need to embrace that. Embrace diversity. So we have a significant number of different technologies in the UK, and previously we've had a big focus on nuclear and offshore wind. There are other technologies. So solar is an important technology, despite the fact people don't think it's very sunny here in the UK. So is geothermal and so is tidal. And we mustn't forget those because those are our key jewels in our crown as a country. And that then embraces best of British. We are really lucky. We have a significant number of different technology capabilities in this country. So we need to invest in those and really think to the future. And then the final one is, this is not a goalpost. This is not a destination 2050. We will continue after 2050. So we have to go through it and then continue at zero carbon. And my personal view is these sets of scenarios really make sure that we can do that. So thank you very much for listening this morning, and looking forward to answering questions later.
Thank you, Juliet. Lovely presentation. Well done indeed for getting a mention of Spinal Tap in there. That's always a test, isn't it? Of course, I'm probably the last person on the planet to know this, but I'll share my only Spinal Tap bit of knowledge, that the reason that Tesla audio systems turn up to 11 rather than 10 is because Elon Musk likes Spinal Tap. I'm probably either the last person on the planet to know that, or it's just an urban myth. Anyway, I don't know. Right, so good. Really great start. Thank you to our speakers so far. We're now going to go to Caroline Bragg, who's Head of Policy at the Association for Decentralized Energy. And she's going to address the topic, Decentralizing Energy, the Principle and the Potential. Thank you. Over to you, Caroline.
Great, fantastic. And good morning, everyone. And thank you so much for having me. I wanted to build on the discussion thus far by giving some thoughts on the themes that we're starting to see in smart local energy systems, where I think we are now and where we could go in future. So to start with, if we think about the themes we see emerging in innovative projects, I'd like to name three in particular. The first one is exploiting the opportunity for innovation that we see as heat decarbonizes and becomes far more localized, particularly through the introduction of low carbon heat networks. I think you can see really interesting work going on, for example, in the Green Skies project that I'm sure we'll hear much more about this week, where they're taking waste heat from the underground and balancing that across the local electricity networks and cooling. I think you can also see that in projects, for example, in Peterborough with its PIRI project that is similarly trying to balance across local electricity and heat networks. The second theme that I wanted to raise is the ability to collect and make use of much more data more quickly at a more local level, to allow local systems to make money from local generation, storage, demand, and its flexibility. I think you can see really interesting projects at the minute in terms of the local energy markets. We start seeing to emerge in Cornwall, in Manchester, the work at Keele University, as well as Reflex Orkney. And finally, the final theme I want to highlight is the role of local governance and community networks in moving forward on many of the themes that we've just heard talked about. I think you can see that in terms of the West Midlands, regional ESO, some of the work, for example, Energize Barnsley, in using community benefit societies and local authorities to drive through projects like Leo that we'll hear about in a moment, and also internationally in, for example, the use of local retrofit coordinators and one-stop shops in places like Denmark to support much higher rates of energy efficiency uptake. So what does that mean, as well as the broader trends we see in energy as we decarbonize, for how decentralized energy could work? We see there being three main characteristics that are important when we look across zero carbon heat, electricity, flexibility, and efficiency. The first one I want to touch on is that earning money from energy, whether that's generation, storage, demand, and flexibility, needs to work much better with normal business and household activities, rather than forcing users and systems into a mold made from the traditional system of large generation and supply. Secondly, we need to get to a situation where the energy system needs to need better information on users and local systems, rather than being heavily reliant on national level data and estimates. And finally, how does that lead into the governance around the system that we have? How do reforms take into account the smart local systems that we're building, as well as users' needs? All of that, I think, means that a more decentralized energy system is one that has transformed from working at a national level across electricity and heat on broad brushstrokes to one that is, and needs to be, far more finely tuned to local contexts. So, where are we now? And are we moving inexorably to a decentralized energy system? I wanted to share some thoughts across markets, information and governance on where we are now, the risks that I see to developing more decentralized energy systems, and what could be needed for decentralized energy to truly thrive. When we look at markets and where we are now, I think it's clear that the electricity markets, particularly the wholesale market and the balancing mechanism, can't really make use of smart local systems and favour larger assets. You can see that particularly with respect to the contracts for difference mechanism, as well as the capacity market. More than that, the markets that can make use of those more localised assets and systems are either quite small, for example, frequency response, or they're still really nascent. If you look, for example, at the DNO flexibility tenders. And finally, on the electricity side, we see that signals that had previously provided a proxy for the value of local flexibility are being removed before there is a clear market-driven replacement. If you look, for example, at network charging reforms. On the heating side, what we see is that it's still dominated by a national gas market, and progress towards more local decarbonised solutions, for example, low carbon heat networks, are still relatively slow, even though they are picking up. Finally, with respect to the markets, I think it's important also to recognise that energy efficiency and its role within local systems is still consistently undervalued, and it isn't integrated into either local or national markets in the way that it perhaps should be. So if we stay on this path, what are the risks to developing more decentralised energy markets? I think the first one is, as ESC have argued, are we going to see even greater reliance on mechanisms such as the CFD, the capacity market, that favour specific larger technologies? Secondly, how fast will we see progress moving forward in building local flexibility markets through the upcoming price control at the distribution networks? Thirdly, will we see energy efficiency that remains dependent on rounds of subsidy with little long-term investment certainty? And finally, will we continue to see growing significant scepticism towards the role of local private networks outside of the licensees within government and Ofgem? Secondly, I wanted to touch on information and where I think we are now. At the minute, the system across heat and electricity has, and I think in some respects needs, relatively limited information about smaller systems, whether that's local network conditions, smaller assets, the flexibility potential. We also see very centralised systems for collecting information, whether that's in the ESO control room, for example, the DNO asset capacity registers. Finally, we also see relatively onerous information requirements needed to be part of these markets and to earn revenue, particularly, for example, if you look at participation in the balancing mechanism. I think the risks here going forward are that we see increasingly onerous and quite awkward requirements for information becoming a stronger criteria for earning revenue, particularly, for example, in the national electricity markets and perhaps in the local ones. And secondly, we could see a continued emphasis on centralised information systems, at least in electricity, that could struggle to manage thousands, if not millions, of assets. And finally, if we turn to governance, it's obvious that BEIS, MHCRG, Ofgem, ESO and the networks have significant influence over the structure of markets and who makes money. And whilst we see local leadership and investment is there, and people are extremely eager to move this forward, it is patchy still, I think. If we stay on the path we're on now, I think the risks that we run to developing more decentralised, more efficient local systems are firstly that underinvestment in local authorities continues and severely constrains our ability to lead and invest in projects as business as usual. And secondly, that we see continued strong emphasis on national procurement and policy control. So to conclude, I just want to give a few priorities on our side for how we reflect on this and how we move to a system where decentralised energy can thrive. I think firstly, on the heating side, it's really clear, and we've talked about it already, that the need to understand local resources better should make necessary more localised information gathering and revenue mechanisms for heat networks, local electricity, reinforcement in markets, and eventually local hydrogen networks. I think there's also a question about whether the scale of future fixed infrastructure costs and the distribution of revenues in the current structure could become increasingly political and drive more appetite for serious reform towards local systems. Finally, I think the lack of progress that we are seeing currently in energy efficiency uptake and what we need for the 4th, 5th and 6th carbon budget could also focus minds in terms of the need to move energy efficiency away from cycles of subsidies towards a longer term sustainable framework for encouraging private investment. On information, I think we're already seeing innovation projects with decentralized information systems starting to compete with the licensed networks in information gathering. And I think what we want is that those continue to develop and grow, eventually outcompeting the systems we have now. With the need for flexibility from domestic and businesses' power and heating demands should also, I think, prompt a more fundamental discussion than we have had to date about how you collect and move energy around, information around a net zero energy system. And finally, I just wanted to make 2 points on governance. I think the first thing is that all roads in some respects lead to local authorities and local actors' ability to invest and move forward local energy projects. We need to figure out if we can achieve a reversal of the centralisation we've seen over the last few decades to allow this to happen. And finally, I think we need to figure out if we have the guts to cede power from national procurement and policy to a much more local level. Thank you very much.
Thank you very much, Caroline, and lovely speech. Particularly, I wanted to echo the introduction of the concept of information and how important that's going to be, amongst your many other good points, and innovation and the tremendous amount of innovation we're seeing in this sector at the moment. So now I see lots of good questions piling in, so thank you for that. Now to move to our last speaker in this session. Can I welcome Rob Saunders, who's the Prospering from the Energy Revolution Challenge Director in UKRI, and he's going to talk about the UKRI Smart Local Energy System projects, proving that it works. Thanks, Rob, over to you.
Thank you, Nick, and good morning, everyone. Yes, so I run this programme called Prospering from the Energy Revolution in UKRI, and I really want to just tell you a bit about the programme itself, but also what we're seeing in the project set that we're funding within the programme, and what we're starting to learn about smart local energy systems, their opportunities, and indeed some of the challenges that the projects are facing in trying to scale them. Next slide, please. So just a really quick bit of context. This programme was put together about 4 years ago now. And at the time, we were starting to see, the really rapid cost reductions in distributed energy technologies, and the benefit of putting the system together across vectors to be able to try and combine across heat and power and mobility and create greater flexibility through that integration. And at the same time, the opportunities from the smart and digital world were really starting to come to the fore, making it clear that we could optimize across millions of assets and active actors in the system. And also, the benefits of local engagement and prioritization were clear at that point in time too. We also saw that this appeared to be a largely non-technological problem. A lot of the technology was there even then, and it was clear that technologies were going to improve and cheapen further. But there weren't business models to put it all together intelligently and that could provide real value to the consumer. Similarly, the investment in complex mixes of assets was difficult and remains so, to be honest. But lastly, there was no proof of value of this integrated smart local approach. So we put together this programme that was funded with £100 million of grant funding from government to try and do that, to prove what's possible. And we started that activity in 2018. Next slide, please. The programme we put together has at its heart this aim of proving investable, scalable local energy business models. And to do that, we've funded a series of demonstrators, a series of design projects looking at different areas across the country, tried to fill technology gaps where we've seen them, done a lot of work recently in unlocking data and digitalization of the system, trying to create open data platforms. We've built all of it on a fantastic research consortium called EnergyRev. We're looking at this whole system of how to put together smart local energy systems. and built tools and capabilities primarily with the energy systems catapults, who are building a fantastic toolkit amongst other things. So we've tried to kind of build a whole set of interventions that can help prove this thing and also enable the system, the ecosystem around it. Next slide. But why local? I think this is what we get challenged on a lot. Why local? Well, there's kind of technical and societal reasons why local is important from where I stand. Technically, a lot of the hard yards of decarbonisation are inherently local. Heat, efficiency, mobility, these are all things that need to be supplied locally. We're not going to pump heat around the country very far. And secondly, you know, the point of use, where we all live, where we all use our power, whether it be in our homes or our businesses, that's where the whole system integrates. It's where supply and demand, heat, power, mobility, the markets, and the way we behave all come together. So that is the point at which you can make the most flexible system, by putting all of that together, using the best smarts to facilitate it. But societally as well, let's just think about that for a moment. You know, we do live our lives locally. I mean, very much so at the moment and over the last 18 months or so, probably more than ever, but we do generally, actually. And we care about the places we live. So we want to prioritise the right things for our areas and do things that make the most of our local resources and the way that we want to make our local areas develop over the coming decades. So we engage in things differently on a local basis. And as David said earlier, we need to adopt things differently over the next decade and beyond. We need to buy energy solutions in a different way. And that is going to depend on us being persuaded by our peers, by the people who live around us, by our local authorities. And I think we know that we can do that much better on a local basis and decarbonise much faster if we can do that on a local basis as part of a national system of decarbonisation. So that's why local from our perspective. Next slide. So we envisage a kind of future smart local energy system looking a bit like this. And let me just say a couple of things about it. Firstly, you know, we're seeing it as a very non-linear system in the future. It's not like the old system that just supplies from a number of point sources and treats consumers as dumb demand points. It's going to have millions of smart actors, whether those be people or bits of equipment, your washing machine potentially, certainly your car smart charger. And it's going to need to be controlled with a very intelligence embedded in the system, much more than we have today. It's going to be multi-vector. It's going to work across heat and power and mobility, and the flexibility across those is going to provide part of the value. And most importantly of all, it's going to be designed for the consumer, for the user at the middle of it, at the centre. It's going to be a human-centric design that delivers the energy services that people want in a net zero world, that makes their lives easier, better, less polluted. So that's our vision for what a system of the future could look like as part of an interconnected national system. We've charged all our projects with working across heat and power and mobility, trying to integrate them in ways that consumers want them, trying to reduce costs and to speed decarbonisation. Next slide, please. We've got activity going right across the UK. So the black dots on this map are our demonstrators. The green dots are our detailed design projects. You'll also see our technology projects in yellow and some earlier design projects in red. Our design started in 2018 and our demonstrators started a year ago, so they're at slightly different stages of development. Our demonstrators are starting to put incredible things on the ground right now. We're probably still a year away from seeing the real outputs and outcomes from those projects in terms of consumer uptake and bill savings. The designs are typically taking a more holistic approach, sometimes to very large areas and regions, and trying to look further ahead at what could be possible for those regions in the future. Next slide, please. Just some quick numbers. So across the programme, we're trying to create connections with almost 30,000 households, 3,000 businesses, 5,000 EVs. So we're working at a scale that hasn't been done before. And we're working across a whole variety of different organisations, nearly 200 in all. I think that was one of our first early learnings, was just how many different kinds of organisations you need to put together to create some of these smart local energy system projects. Local authorities are often at the heart of them, energy suppliers, energy service providers, data companies, smart energy companies, energy hardware companies, as well as consultancies and EPCs, 20-odd universities, and of course the Energy Systems Catapult. So a real cohort of different organisations working across the communities that are engaging in this programme. Next, please. So let's tell you a bit more about what's actually going on in these projects. And we've started a series called Voices from the Energy Revolution, which are people working within these projects, giving some brief snippets of their experience of smart local energy systems and their development. So let's hear a bit, just short clips from those, of some of the opportunities that these projects are seeing in their work. You can play the video, thanks.
It's all about providing flexibility from assets that are connected to the electricity system in Oxfordshire, so that we can free up more space for things like electric vehicles and low carbon heating technology.
Our goal is to significantly reduce the cost of achieving net zero for the energy consumer and ensure no one is left behind.
In time to come, we know that we're going to be able to talk about Energy Superhub Oxford as a major innovation in the decarbonisation of transport.
We have a great deal of enthusiasm from the local population, who are the stakeholders and who actually own the port, who know that a local energy system such as the one you see behind us is going to be a solution for the future, producing less pollutants and producing less carbon.
Great. So you'll have heard some of the views of our people working in the PIFA projects there. What I hope you heard was that there are some real opportunities from doing much more with our existing infrastructure, from creating much more fairness and reducing costs for people, and also just the power of innovation in being able to create new services and new net zero worlds for people. So let's just have a quick look at some of those in a bit more detail. Doing more with less, two of our demonstrator projects are focusing heavily here. Project Leo in Oxfordshire, which we'll hear more about during the week, and Mel is on our panel later in this session, is really trying to embed intelligence in the local network there, so that we can embed more community renewables, deliver new services off that backbone, that intelligent backbone, and balance the system much more effectively in those two sides of it, so that we can have our new services, we can put in more renewables onto it, and we can balance the whole thing with that intelligence. Project Reflex up in Orkney is perhaps a fairly unique case right now, where they generate about 130% of their electricity demand in renewables, and they can't export a lot of that excess. So they're really focused on how do we make most use of that renewable resource for our local area by creating a more flexible, more dynamic system that local inhabitants can take part in, make use of it in EV infrastructure across heat and power services across the islands. Next slide, please. Secondly, you heard some real opportunities in lowering bills, not leaving anybody behind, and the fair transition. Project RESO, which is based in Coventry, looking at the opportunities from a regional energy system operator, trying to bring that whole city's energy plan together into a local market, but also, and critically, trying to really embed the opportunities of retrofit, improving building fabric, putting in the right smarts so that we enable people who don't have the available capital to get at the forefront of this to be protected, and so that they can be part of that transition and also benefit from it. Next slide, please. And lastly, we heard about the power of innovation in creating better services for us as consumers. Energy Superhub Oxford is one of our demonstrators that's putting a huge hybrid battery connected to the high voltage grid, off which they're running super fast electric vehicle charging across the city, partly for powering the city's fleets, city council's fleets. They're also running smart heating off that system and controlling it all with an AI-powered intelligent engine for trading into the markets. Greater Manchester's design project is taking a holistic view right across the combined authority area, trying to figure out how do we make the best use of our resources, how do we put in the right new resources, and then put the whole thing together in a local energy market where actors can take part in the market in a completely different way. Consumers can engage to provide that flexibility across the whole region and into the national system. Next slide, please. And if we just look at the opportunity a bit more systemically as well, so if we chunk up a level and think about what the size of the prize is, well, recent research shows that we think there's up to 8.7 billion per annum in system cost savings from doing this well, which would otherwise hit consumers. This is mostly based around the extra flexibility you can achieve. We can join up net zero for people in much more significant ways by taking a local approach and engage them in new systems that they want and drive net zero faster as a result. We can implement resilience at multi-levels so that the whole system overall has improved resilience rather than degraded. We can accelerate change through engaging people in ways they want to be engaged. And last but not least, we think there's a really significant opportunity in business growth and in jobs to level up across the UK. These local energy systems have the potential to capture more value of the energy system overall at a local level. And I'll show you a bit of work we've started in a couple of slides' time. Next slide, please. In terms of the system savings, this is the results of a piece of work that Imperial did last year, looking at system cost savings from increasing levels of smart local energy systems and the different carbon intensities for the whole system. And really the key takeaway here is that SLES is driving more flexibility on a local basis, increase the savings to the system as you get more of them, and they increase as we ratchet down harder on our carbon targets. The savings come from the increased flexibility enabling more wind onto the system and displacing higher cost generation. They come from savings in the networks, the yellow bits of those bars, and they come from savings in other parts of the generation system. But these are very, very significant numbers that we have to try and take advantage of, I think. Next slide. And on jobs and growth, we've had PwC doing a bit of work for us over the last few months, trying to look at what the jobs and growth potential from local approaches to net zero are across 5 cities in the UK that you'll see across the top there. These are very early findings, and numbers will change. Well, let me just draw your attention to a few lines. Firstly, the top line, the investment in each of these cities will be very significant. But 4th line down, the private cost ratio benefit, sorry, private cost ratio benefits of those investments are all positive. So these are good things to do. Looking further down, the figures in green are the GVA growth that those cities will experience from those investments. Again, pretty significant. And jobs at the bottom there, tens of thousands of jobs in cities right across the UK from taking these sorts of approaches. So we all want to capture this kind of stuff. We need to get on and figure out how to do it. Next slide, please. And figuring out how to do it, well, we've seen the opportunities that all of our projects are talking about, but they're also all facing, some pretty chunky issues as well. Let's have a listen to what their views on those are. You'll play the video, thanks.
Three big challenges we face in reaching net zero are making the grid more flexible to enable more renewable generation, delivering charging infrastructure to accelerate the shift to electric vehicles, and replacing inefficient heating systems with clean, renewable heat.
The problem we've got at the moment is that our energy system hasn't really changed much since it was developed. So a large part of all of our energy bills are spent either upgrading or maintaining it.
A lot of houses will need to start installing electric heat pumps and electric car chargers at home. The problem is our electricity network was never designed for these types of technologies that draw a lot of electricity.
Creating smart local energy systems that are vital for reaching our net zero aims relies on everyone taking part and changing their behaviour in some way.
So, some issues to get through in making this stuff happen. What you saw and heard there is, this is a whole system transformation that we need to go through. A lot of the barriers that we're seeing and that we're trying to address are that financing needs help with the complexity of SLES projects. Capacity locally is, capacity and capability is great in places and not so great in others. The incentives and markets aren't aligned at the moment to deliver the benefits that we saw earlier, and we will have to change those if we want to capture those benefits. Policy and regulations are creating shifting sands without a long-term trajectory for businesses to follow. And consumers need to be engaged in ways they want to if we're to expect them to do things differently. And lastly, testing and demonstrating is hard in a highly regulated sector, and we need to see that being more flexible. Next slide, please. So, in summary, we are trying to prove what can work, and we've got a fantastic set of projects that we're busy learning from that are doing world-leading things. There are really significant benefits to be had from local approaches to net zero, but right now the incentives don't line up to deliver those benefits, and we need a change across the system to enable those benefits to come through. So our proposal actually fits very well with some of the things that David was talking about earlier. We do need a review of how local and national systems can work together to deliver the best net zero for the UK, and that needs to come very quickly, I think. Thank you very much.
Thank you, Rob. Thank you to all our speakers. I think that's a really great start to the conference. Just picking up the 8.7 billion, which good figure, and really just very important in terms of economic welfare. But of course, to add to that, I think we all know that the challenge of getting to net zero in these timescales is so huge that it's not just about cost. It's about we need these local energy systems to develop to get us there in anything like on time. So we now move to the question session. Our speakers are still with us and are joined by Melanie Bryce from SSE Networks, who's working on Project Leo in Oxford, and Jeff Hardy from the Grantham Institute, who's very involved with the PFA work as well. I did just, I'd like to give Melanie and Jeff just a couple of minutes each to just add anything they want to what's gone before. Can I go first of all to Melanie?
Yes, hello. Thank you, Nick. Thanks for chairing the panel today. Yes, I am the lead on local energy Oxfordshire, and I'm just going to give you a brief overview of the project in a couple of minutes, which should help with the panel discussion. So LEO is very much demonstrating the smart local energy system. We're looking at developing a series of pilot projects across aggregated load, micro hydro, batteries, everything that you can think of really. And we're looking not only at the technical challenges, but also the kind of regulatory and market-based challenges, and not at all forgetting the social considerations, which are so important in the energy transition. So we're really looking to inform policy change and being able to further local investment in renewable energy. So we also bring the Ofgem funded transition project, which is looking at developing the IT systems to develop flexibility at the local level. This is a huge whole systems project. So we've got participants and partners from across the whole of the energy industry, which really helps in terms of, we have the Low Carbon Hub, who is a social enterprise in Oxfordshire. We've got EDF Energy, we've got both councils, the universities, ourselves as the network company, sort of picking it all together. So yes, we've come across a few challenges. On the technical side, we've learned a lot about building management systems and batteries and how we need to make sure they're configured correctly. And on the market side, looking at things like baselining and settlement and confirmation of when an event has been delivered. And one of the real advantages of being part of such a strong consortium is that we're able to talk about pricing as well. So pricing for these services that are going to be required to encourage flexibility. So we've got 5 main services. We've got 2 which are DSO centered services, and then we've got another 2 which are more about peer-to-peer services, so how we can make the best use of the electricity network through exchanging capacity and access rights at a local level. So the trials start in November. So we've been setting up until now. We've done a few sort of agile tests to make sure that everything's going to run smoothly. And we are initially going to be demonstrating using the assets that the LEO partners bring. But as we move further forwards, we're going to be bringing in wider participants from the community. And we've already had interest from people like Thames Water, Tesla and Octopus. So LEO is really, the large demonstrator project for smart local energy systems. And yes, I'm looking forward to taking part in the panel discussion. Thanks, Nick.
Good, thank you, Mel. And over to Jeff for a couple of words.
Thank you, Nick. So as Rob said, I'm part of the Energy Revolution Research Consortium. So this is an academic consortium that's working within the Prospering from the Energy Revolution programme. So we've got the privilege of working alongside all of these projects that you've heard about today. And what we're trying to do in this is trying to bring cutting edge research on the technical, economic, governance, operation, experience and replicability of these smart local energy systems. So within Energy Rev, I'm responsible for our work in future smart local energy system governance. And really, this is all about what changes are needed to the policy and regulation to let SLES do its thing, carry with it all of its benefits and avoid any harms that might be coming from it. So just a few quick thoughts on what we've heard today. Firstly, I think we've heard really clearly from Juliet and from Caroline that this transition, whether it's called a smart local energy systems one or not, is inherently a local energy transition. All of these aspects like local generation, local heat, local transport are all going to be dealt with locally. Secondly, we've done some work on post-pandemic economic recovery as part of the Energy Rev Consortium. And one of the things that we said was that if you adopt a smart local energy system approach to delivering net zero transition, we think it could be faster than other approaches. We think it could be more cost effective, which is what Juliet was saying. We think it could be fairer, and we think it could bring with it more benefits, so co-benefits, things like health from better air quality and warmer homes, that kind of thing. The fairer thing's really important though. We recently published a paper in Nature Energy, which basically says that there are people who could be locked out of an energy transition because they can't or they won't engage. It's a really important distinction. I think this really puts an important emphasis on the business models that are going to be operating within smart local energy systems and the way in which they're going to be engaging. So one of the things that we're looking at the moment is what space is going to be required within regulation to allow these new business models that we've heard a little bit about today to come into the market. This is something that Ofgem have recognised in their innovation link review that they're doing at the moment, where one of the main findings they have with the energy system is that the supplier hub is a real barrier to innovative business models of the sorts that smart local energy systems want. The other thing that's really important here, which we've heard about a few times, is that many of these businesses rely on stacking up value from multiple things. So assets can provide multiple benefits to the energy system. Things like domestic demand side response, running your electric vehicles flexibly. However, those values are really difficult to stack up at the moment because of the different rules in different markets across the system. So there's a lot more whole systems thinking needed with a smart local energy system lens in that. But at that point, I'll be quiet because I'm dying to hear some of the questions.
Thank you very much, Jeff. So let's go straight to the questions. There's lots of questions. So I'm going to look for the panelists to chip in, keep their answers reasonably short, please. So the first question, which is a good start, really, which is a question for me, which I can't answer, but I'll have a go at saying something quick about it. The question is just curious about this local planning. Is it possible to know how this planning links into the UK NREAP, Renewable Energy Action Plan? All I can say to it is the Catapult has done a lot of work on local plans with local authorities. Lots of local authorities are clearly involved with the work that Rob is doing on PFA. One of the interesting questions that we're trying to tackle is how to integrate all of these jigsaw pieces of local planning, make sure they're on the right they're all on roughly the same basis, and you can integrate them into a national picture. But I can't add any greater value than that. If any of our panelists want to add to that, I'm just going to give you the chance.
I'll start if you like, Nick. I think that local is so important, and that ED2 is going to play an absolutely critical role in getting this right. We need to make sure that local authorities are supported in their plans, and that ED2 is ambitious enough and aligned enough with net zero to be able to get us to where we need to be. So that would be my first point on that. And then my second point would be, as part of the project, we're developing an integrated mapping tool. And I think this is something that we're seeing more and more, which is really going to help the energy transition to happen at the local level. So it's the surfacing of information to help that transition take place. So those are my two thoughts on that question.
Okay, thank you. I think we're going to keep moving through the questions. And then the next question was, including population and industrial growth, question mark, what are the projections for electricity consumption? David might be the best person to turn to for that.
Yeah, absolutely. Thanks, Nick. So in our what we call our balanced net zero pathway, we see a doubling of electricity consumption between now and 2050. Most of that extra electricity is used in electrifying heat, electrifying transport, electrifying industry, but in the most efficient ways that we can. We actually have other scenarios where demand might triple if we start using electricity, partly because renewable electricity becomes so cheap. We might find ways of using it a bit less efficiently to help decarbonise. So that might be using it for things like electrolytic hydrogen, making synthetic fuels for aviation, for example, and those sorts of things. So somewhere between a doubling, maybe a tripling, maybe even more than a tripling, depending on what happens on the economics and technologies and so on.
Thank you. And I think one of the really interesting things about it is also start thinking about the amount of storage we might need on the electricity system to facilitate that, which we haven't touched on much today. Let's keep going. Juliet, in terms of charging commercial customers for renewable energy, have Good Energy any plans to introduce half-hourly settlement to reduce overall cost of energy and allow clients to manage when they take power? And that relates to commercial customers. As a customer of Good Energy, perhaps I shouldn't say that, but you know, when for domestic, when do we domestic customers get half-hourly tariffs?
So I think that there's quite a significant number of commercial customers already have half-hourly tariffs. I mean, it comes back to some of the work that Ofgem is looking at the moment in terms of how the different parts of the market is settled. And in fact, I mean, I think this is the theme that's been coming through, is that how do we pass value of changing behavior back to the consumer? So in the half-hourly market, in the larger consumer market, we've already got flexibility markets starting to establish. They've never really been established for the SME market, which is non-half-hourly, or the domestic market, which is non-half-hourly. That is what we are looking at the moment for settlement. And I think that, I mean, we are seeing some tariffs come through already that are half-hourly settles. They're experimental tariffs. They're not true value tariffs, and most of them are losing money, but they're kind of trying to explore this area. The faster we can get the regulation to underpin a half-hourly settle system, the better, and we will be able to roll that across the whole portfolio. But Good already offers half-hourly in certain marketplaces, just not in all of them, and we're reflecting the status of the regulation in the market.
Thank you, Juliet. So next question was focused to me, although others I think would probably have more value on it. Energy storage facilities are also required to be designed locally, but this may have environmental issues and several other risks. Are there plans for nature-friendly energy storage facilities through R&D? I can comment a tiny bit on this. I do believe, actually, looking at the strains that are going to be on the electricity transmission and mainly distribution, that we will have energy storage in terms of batteries, quite likely have it at many different levels of the electricity system, right from offshore, next to offshore wind, right through to people's house walls or garage walls. I think how to think about the environmental issues of using those technologies, it's the same as the environmental issues. We have to take account of the whole of the system and try to balance out the least environmental impact, whichever, you know, what all technologies have that associated with it. Do any of the panel want to chip in on storage facilities? And please, if you do, just speak.
I think we're beginning to see some alternative storage facilities come through. I mean, I think Nick, there are two ways of seeing new ideas come through to this market space. One is through the R&D and innovation space. So calls for kind of these types of technologies coming through from the different research bodies would be an important route and an important sort of prod to make that happen. And I think the other side is that it is difficult to really start to build a business model unless you see the value that you can create and the value you can deliver. And so I'm actually involved in a organization that's looking at using old mine shafts to generate sort of very fast frequency response power. Sort of trying to use existing infrastructure to deliver some of these things. But we do need to see the economic framework shift so that we can actually get the benefits for these technologies.
Thank you. And moving on to the next question on skills. Skills was touched on by a number of our contributors. The question is, it'd be great to know more about the skills task force. The net zero agenda seems to assume that the STEM talent pool will be available through the existing HEFE apprenticeships. Specialised training will be needed, ? And of course, that's a fantastic opportunity for me to do the thing I like to do in every meeting I attend these days, which is to mention the plans for the National Centre for Decarbonisation of Heat, which we're trying to get agreement for, based at Tyseley in Coventry, which the idea is to have a major facility for retraining heating and plumbing engineers. I think somebody said there's 200,000 out there that will need retraining. That's an important thing we're pitching to government at the moment. So I think the questioner, I don't get the names of the questioners, but I think the questioner is right in saying we think we'll need more than just the HEFE system to do that. And I suspect, 10 years on, we'll see training centres spread across the country, retraining for the green agenda. Can I give my panelists a chance to chip in on the skills question?
I think I would just add, if I may, I think it is, as you say, widely acknowledged now that we will need much more investment in skills if we're going to do this properly. I guess the other thing I would notice, I think some of the interesting stuff that's come from BEIS recently is that the bottlenecks that we'll see, particularly in heat decarbonisation, are actually really quite varied and quite significant. So you see it in terms of engineers, installers, for example, that you need, but you also see it, for example, in people with good project management experience in some of these larger infrastructure projects and on the commercial side.
And just to build on that, I think that the engineering capability is one big area we're going to need. We're also going to need investment in data, IT, and capabilities of managing these diverse systems. And that is the other gap. And one of the things, I think, Nick, one of the big concerns that I have personally, and I think is becoming to come through, is the diversity in that talent as well. Making sure that talent has a diverse set of people in it, and that we do have more women in the energy sector than we've had previously, more people of colour. So there are some big challenges to make sure that we represent the people of the future in the industry of today.
Fantastic, yeah, and I 100% echo that, Juliet. And I would also like to draw attention to the data and digitalization apprentices, and how we would like to see more of those apprenticeships available, because those are the skills that we're going to need going forwards with the amount of data that we're going to have. We're going to be able to be working much smarter, but as well as the traditional engineering skills, I think getting people who are multifaceted and able to do engineering and data and digital is what we need to be able to get through the energy transition.
Thank you. Let's go on to the next question. Can you comment on the quotes electrification of everything, given, number one, what happened to the Texas blackout earlier this year, number two, high cost and inefficiency of home electrical heaters, brackets, my home has electrical heaters, my bills are really high. I'm going to try not to comment too much on these questions. I will take that one though, because I have obviously spent a lot of years running the electricity system. The Texas blackouts, I don't think tells us anything about this. Electricity systems over the years have always had significant risks of instability that need to be managed, and always have been managed, and that's the job of the utilities that run those systems. The challenges are changing, and as you've seen in the UK, we've got a dramatically changed energy system now, where the system operator has learned to cope with much greater levels of renewables than we'd ever expected, and all of the consequences of intermittency and system inertia and so on, and we see the system coping extremely well. So I think the Texas blackout does say we need to think very hard about these issues and plan ahead, but I don't think it's a warning to not go in this direction.
Can I just make another comment on top of that, Nick? So I think a lot of modelling both in the UK and globally basically says several things about any zero carbon future system. One is it needs to be incredibly efficient because that drives down the amount of generation, network, and everything else you need to do, but it also keeps bills regular. It needs to be very flexible because most systems are incredibly renewable driven. So you want the demand to be following available supply, because when the wind's blowing, when the sun's shining, that's when power should be incredibly cheap in those systems. So you want a lot of baked in flexibility, automation, etc. But it also needs to have something in it that brings all of its users on a net zero journey as well. And that's what we're really missing in the UK at the moment, is any sort of intermediary who's going to help customers through what could be a very complicated and upfront cost-driven system in the future. So we're going to need much more user-centered suppliers, for want of a better word, in this space, who are going to help customers through that upfront cost journey, and also help them through the complexity of much more, say, half-hourly settled prices, so complex kind of pricing and that kind of thing. Really important. Those are big priorities, and those companies could be incredibly local because energy systems could be incredibly local and different in different places.
Thank you. Let's move on. What proportion of domestic heat and hot water could be met by district heating? Let's go to David, potentially Juliet, from the modelling point of view.
Nick, our analysis has around 20% of buildings being supplied by district heating. Essentially, that's a function of the economics, which in turn is a function of the density of heat demand in a given area. So it tends to be in heat dense local areas in urban areas. It could be, you could get to more than that, but fundamentally it's a function of the cost of the infrastructure versus the value that it brings in terms of serving enough customers.
Thank you, David. Yep.
I think there's some interesting sort of technologies that are coming in that are kind of hybrid between district heating and heat pumps, where we're seeing kind of low-grade heat networks being used and individual heat pump units within households. And I think there's some quite interesting innovations that are coming through in this. In the scenarios, we see kind of large-scale heat pumps sort of taking nearly sort of 30% of the total heat load, which is a kind of district heating type heat pump. So I think there's some innovations where the old form of district heating, as we've thought about it, maybe burning something, creating some heat and then pumping it around a building, is going to shift a little bit, because you can have a low-grade heat network with individual small heat pumps within homes that then concentrate that low-grade heat into the household. So there's some kind of this is an area I hope that we're going to see more R&D and some more investment in, because for me, heat pumps are a great technology that could just get even better.
Yeah, I absolutely agree with that. And I think one of the great questions facing us is what economic models, what markets, what regulation, we need to encourage in district heating. Question for Juliet. No technology is zero carbon, including wind turbine, solar and nuclear. So how is your scenario reaching this target? As I think this is about embedded carbon.
I think it is about embedded carbon, Nick. It does depend how you generate your embedded carbon in the first place, because obviously if you assume an overall system goes towards zero carbon, then if you've got wind turbines producing wind turbines, then your embedded carbon goes down. But I can answer that. There is some CCUS in the model. I mean, to be honest, most of it sits with the biomass. So in our model to create green hydrogen. So that's where we're seeing the majority of it. In terms of embedded nature of carbon, that is a timescale piece, depending on where you are producing, where you are manufacturing your assets. So do we move to a green steel industry in the UK? Do we see that being centered around hydrogen hubs? I personally think so that you could start to see actually the embedded carbon within our systems reduce over time.
Thank you. And a couple more questions for you, Juliet, which I think you can read on the screen. Building regulations, how will they need to be changed? so that new builds have mandatory installation of renewables. Yes, and we're all worrying about that. How will existing homes be brought into the mix? We might hear from David and others on that as well. And hydrogen is a good solution, but what capacity level of hydrogen systems can be deployed on site for larger pilot locations? What are the possibilities? What are the possible H&S requirements for the installations? That's health and safety.
Okay, so I'll whiz through those and then hand the rest over to everybody else. So if I go backwards, on hydrogen, I think I touched on it. I mean, hydrogen hubs are a really interesting way. You can confine the distance that you're taking things. You can look at creating localized industry where you're using hydrogen. And you can actually potentially in the future, I mean, the scenarios that we run didn't use a lot of offshore wind, excess offshore wind to generate hydrogen. But if you're looking at hydrogen hubs, it would make a lot of sense to be taking where you're taking power off large offshore, creating hydrogen and then creating those in their hubs. My personal view is pumping it around the existing gas network we spend a lot of time, put a lot of effort putting that in when actually we should be thinking about other innovative solutions. Nick, I've forgotten the other questions. Sorry, I should have written them down as you said them and I was answering them in my head as I went.
Building regulations.
Yes, I mean, yes is the answer. I mean, I think there's a no-brainer on building regulations. We shouldn't be allowing construction industry to pass the issues of the exist today over to tomorrow, which is exactly what we're doing when we build inefficient homes with not enough solar thermal heating in them, with not enough other technology. So solar thermal is an important technology, PV, heat pumps, and electric vehicles, smart charging systems embedded in a house. Absolutely, all homes should have that today.
And just recognizing, looking at the list of questions that we're going to not get through all of them. So I'm going to just open up to the panel because they were some nice general questions just there. Let's open up to all of the panel to chip in on those, but also to pick out other questions that, you know, particularly if you think there are ones later on, because of course questions have come in order. So they've sort of come in mainly focused at Juliet at the beginning. So do have an opportunity. I'm going to turn to each member of the panel to get some value out of answering some of these questions. David, you could start on building regs, I think, and how the CCC sees the importance of building regulations.
Thanks, Nick. Yeah, well, so we absolutely agree that new homes should be built to be essentially net zero compliant as soon as possible, because otherwise we're just adding to the challenge, and decarbonising the existing building stock is going to be pretty difficult. Let's not make it even more difficult by adding to it. I would say that having on-site renewable electricity generation is less important than having zero carbon heating in those buildings. You can always get decarbonised electricity from the grid, whereas getting decarbonised heating once you put in a fossil boiler is much more problematic. So for me, that's the priority. Picking up another question that I saw about electricity and gas pricing, we think this is a really important area. If you're going to have electrification of a range of things, including heating, electricity is just too expensive at the moment, and that's because of a policy choice that was made. We can change that policy choice and take the costs of previous policies off electricity prices and either put them onto gas or just pay for them through taxpayer funding. We also need a fair solution on carbon pricing of low carbon heating in different parts of the country, so that those who are still on gas are not getting an advantage compared to those, for example, who switch to a low carbon solution, which might be a bit more expensive initially at least. So that's a crucial area. We've seen encouraging noises coming out, at least from the newspapers in terms of in the Times in the last few weeks, that balance is going to be changed. So that's encouraging, but that's crucially important if we're going to get the sorts of changes we've been talking about.
Thank you, David. Now I'm going to give each speaker, because it's clear we need to finish in about 5 minutes, each speaker a chance to just pick up final points from the questions or other things they want to say. I'll come to Juliet last because you've got quite a few questions anyway. Caroline.
I think just building on some of the discussion we've just had, I think there is some interesting questions around existing buildings and how we decarbonise them. I think the way that we would see it is that you start with the ability to incentivise private investment. And I think some of the work that the Green Finance Institute has done, for example, around linking it to mortgages and the value of the house is really interesting. And then that needs to be backed up, though, by we think stronger regulation. I think if you look at, for example, the private rented sector, we've now got a little bit further forward in terms of minimum energy efficiency standards that support that. But that's not across tenure, and I think it creates a slightly weird situation. And then finally, as we've said, I think we do need to have a conversation about much more significant support for those less able to pay, both on the heat decarbonisation side as well as the efficiency.
Thank you. Now, in terms of the rest of the questions, also I should note at this point that there are huddles afterwards with some of the speakers that you can go on. There'll be some instructions how to do that. So those questions that aren't answered, you might be able to ask them to specific speakers then. Rob, can I go to you to pick up anything you see in the questions?
Yeah, thanks, Nick. Yeah, firstly, just to weigh in a bit on the kind of pricing and incentives thing. It is something that all of our projects are seeing, is that just the lack of any long-term trajectory on these things is as much of a problem as the overall kind of discrepancies. You know, the projects, when they put in their proposals 3 years ago, were operating under a different charging structure from the one that emerged and the one that was expected. And so what they could do under the changed regulation system was different from what they'd expected. And I think it's just that constant shifting sands that cause problems as much as anything else. We need to have a trajectory. And, you know, this issue of electricity versus heat pricing and policy costs distribution across them is really difficult politically, because as soon as you put the price of gas up for any reason, you're putting a load more people in fuel poverty. But if you do that over a really long period of time, and set the expectation, you know, with the right leadership of explanation around why that's happening and the better world we can create from doing it, then that seems very doable to me. But we have to give businesses the time and the runway to be able to build their business models around that trajectory. So yeah, that's my viewpoint on that. There's an interesting question in there, which is what are the key questions we should be asking and addressing in feasibility studies looking into the potential of SLESs. And I think there's a couple of really quick answers to that. One is, you know, who are the organisations that are going to be able to pull a smart local energy systems together in your area? Who do you need to get together to make that happen? And the second one is, you know, what are your local priorities? What are you trying to do? Are you trying to protect a lot of vulnerable customers with what particular issues around that? Do you have massive local resources to take advantage of? And I think the third one is, you know, having a look at what data exists for the local area and how to get better data so you can plan it appropriately, taking that whole system into account.
Thank you. Mel, final comments?
Yes, I think that the comment that I would probably like to end up with is very much, I think it's been mentioned a few times, but the securing a fair transition. In Leo, we've got 5 what we're calling smart and fair neighbourhoods, and we're very much working with the local community on things like messaging, on communications, developing very easy to understand animations as to what it is that we're doing with the project, and then looking at how we can engage with them and then look at the fairness of what it is that we are proposing to put in. So I think that's an absolutely key piece that we mustn't lose sight of as we move forwards with the energy transition. And the only other thing I wanted to add was there's also a lot of ambition. There's ever such a lot of ambition on the call and generally, and it's really making sure that we've got the clear policy to underpin the way forward. I think probably echoing what Rob has just said, to have some sort of security so that people are willing to invest and that it's not going to change you know, too quickly. We need some absolute surety going forward to enable people to invest in this. Thank you.
Thank you, Jeff.
Thanks, Nick. It's good that I come later in the queue because loads of the good stuff's been said. I think one thing that gathers together a few things that have been said already is that whilst we have a zero carbon target in the UK, we don't have a zero carbon UK vision. And that I think we miss, because a lot of these are all elements of that. And I think that is for government to start that job and then decide how and where responsibility for delivering that is going to be. And if that's down to local levels, then that's all good. I think the second thing, as an ex-Ofgem regulator, the thing I wanted to pick up on, there was a question about, does Ofgem have the breadth of remit to join up locally and enable a timely way to catch the wave? And I think Ofgem certainly has the remit to do that, but I would argue at the moment that Ofgem itself is quite siloed in thinking about local. I remember being in Ofgem and having a really good local issue come to me, and I had to bring 8 teams together to answer it. And that tells you a little bit about how cross-cutting these smart local energy systems are. So I think what it really entails is that Ofgem needs to think much more whole systems in how it does its regulation. And secondly, it needs to be less prescriptive and more principles or agile regulation based, because you don't know what innovations are coming. So let the flowers bloom, but have a commensurately large hammer on the other side of that to stamp down on bad behaviour.
Okay, good. And finally, to Juliet.
Thank you, Nick. So many questions in here, but I'll see if I can sort of try and answer 2 together. There is a question here talking about R&D. If there's greater need for R&D to be done, what's the certainty we get to the 98% renewable target? Well, to be honest, there's no certainty. I mean, the idea of the scenario was to show that you can do it with existing technology and existing knowledge. My view on R&D is, I think it's across the system. It covers everything that's been talked about this morning, whether it's regulation, whether it's local policy, whether it's how local agencies work together to deliver this. What's exciting is that I'm beginning to see the language at an innovation level start to talk about the fact we need innovation in regulation as well as in technology, as well as in behavior and economics. I think there's another question that comes through, is talking about how are people going to pay for this if this is going to be particularly focused at household level. And I think this is a really interesting and potentially very easy challenge. There is so much money that now wants to be spent in the ESG area. We have every single pension now having some pressure put on it to go green, because up to about a year ago, I know from a good energy point of view, we could not invest in a mainstream green pension. All of them had exposure to fossil fuel. And so all those pensions are going to come under a huge amount of stress to be able to put into this area. There will be capital available. It's just, how do you then chunk that up so that it comes out at a fair level across the whole of the population? And that's a piece of work that we can do in R&D. There you go.
Right.
Thank you.
Thank you, and thank you for all the really excellent questions. I hope some of the ones that weren't picked up on will be able to be taken forward in the huddles. But anyway, we'll capture all of these and think about whether we can actually answer some by posting some answers in collaboration with the panelists. But we are, alas, out of time. So I just want to close this session by thanking all of you for dialing in today and taking part. Thank you to the speakers who on all of your behalf, I'll say to them, I thought they did an absolutely fantastic job. Very concise, brilliant content, well done speakers. And just to advertise that the next session starts tomorrow at 10 a.m. Covering the business aspects of SLES. Don't forget the virtual exhibition, and don't forget the opportunity to go into huddles with the speakers. Thank you. That's the end of this particular session.